You're here for On the Map. If you're in the wrong room, you still have a few seconds to try and escape and find the right session, but hopefully you've seen this slide for long enough that you're in the right place at the right time. So we're going to cover advanced mapping and spatial analysis with Tableau today. You have the luck to have two presenters. You have myself and you have Rachel. Rachel and I actually used to work together before I joined Tableau at a GIS company based in the UK called CADcorp. And Rachel joined us there as a graduate. She came in with an MSc and started in the QA department testing our software to make sure it wasn't full of bugs before it went out to our clients, something I'm sure you're all very happy about. And then she actually moved over to work in the customer services area and went out on site delivering spatial analysis solutions to my clients and actually making sure that they were able to solve their spatial problems. I then left 3 years ago and joined Tableau. And it is an amazing place to work. If you want to come and work at Tableau, come and see me because I do love referral bonuses. They are very good. And I said, Rachel, you've got to come here. You've got to help me get some money, and you've got to have a lot of fun. And so she did, and that is why she's here today.
Yep. So when I met Andy, he already had around 15 years experience in the geospatial industry, working for clients in the oil and gas sector, the emergency services, and even the British Antarctic Survey. So he was always a key person for me to go to when consulting for our customers to get ideas and things like that. And I'm glad I did join him, because it means I can be here today with all you lovely people. And there's one more thing you should know about myself and Andy before we go any further. There's one thing we love more than a good map. That's a good selfie. So this was on the pitch at Twickenham where we learned the hacker at a Tableau event. So again, if you want to join Tableau, we do lots of fun things like that. And you could give me the referral bonus instead of Andy, just saying.
Come and see me afterwards. So why are we here today, and why is there a big picture of a tool belt on the screen behind me? Well, that's because this is an advanced mapping session. A lot of what we want to do is extend way past what Tableau itself was designed to do. We want to take you outside of what Tableau does natively, and we want you to feel comfortable being able to reach for all sorts of different types of tools to complement what Tableau offers and to be able to extend the range of spatial analysis questions you answer on your dashboards for the people you're building content for. And we're going to do that today with the following agenda.
So the agenda that we've put together today is inspired by customer stories from guys just like you who are struggling to answer these business questions. So we've changed the data a little bit, but they're all coming from customer examples. We're going to start the journey today inside Tableau. So we saw some really good, cool things in the devs on stage just now. So we're going to cover what we can do in Tableau currently, but also it's important to know where the limit is what we can do with Tableau and where we can turn to when we hit that limit. So then we're going to look inside your spatial database. So did everyone get really excited by spatial joins that Kent showed? Pretty cool, right? So we looked at intersect, but there's a great range of different features that your spatial database is capable of, and you can call out to them using custom or raw SQL and have the analysis in your dashboards too. Then we're going to look at the external services connector. So I don't know if anyone's familiar with this already. Sorry, I was confused by that rumbling. So you can call out to R or run Python code or even MATLAB within your calculations within Tableau and call out to spatial libraries powered by those services and have the results within your dashboard as well. And then finally, we're going to look into GIS software. So for anyone who's not familiar, it's Geographic Information Systems. So this is a specialized tool just for spatial analysis. So we're going to look at how we can use GIS software as a data prep tool and bring that data back into Tableau to answer even more business questions that you have.
But first, a subject that quite literally underpins every map that has ever been made, projections. So we get lots of queries on a daily basis from all of our clients how to help them understand what's going on, and they're trying to answer more questions. And a lot of the feedback we got from TC was that people don't understand this topic. And the reason that we want to give you a good grounding in what projections actually are and how they work is because a lot of the topics we're going to cover later, when you go a bit more advanced and you use tools outside of Tableau, this subject really, really matters. And we'll talk to you about why you need to understand these as we come onto them. So first we're going to help you understand a bit more about projections with a live demonstration, which normally I help with when I have a lapel mic, but I don't today. So Harry is going to help here. There is a warning as well. There are quite a few acronyms about to be fired at you.
Please hold this very high.
So what we have here is the Earth, literally. Harry's got the whole world in his hands. And what we've got to do is we've got to try and fit this completely spherical object onto your computer monitor or onto a flat piece of paper. So what we need to do is cut it up to start with. So if Rachel can cut down...
Where should we cut?
cut down the Mid-Atlantic Ridge. We could cut down the zero line and see what happens if there was a physical Brexit. But
we thought we'd keep
we'll keep politics out of this. We'll just go for the Mid-Atlantic Ridge for today.
Oh.
This ball's bigger than the last one. Okay, right. So there we go. Right. If we pull this a bit, you can see that that's still not really going on a flat page. Okay, we've got lots of creases, wrinkles, and it's just not working. So the options that we've now got are we make thousands and thousands of cuts. Does anybody want a map that small? No. Or we start to stretch it. So if we take, because we're at TC Europe, if you cut out Europe, let's find Europe.
I've got it. I've got
You got Europe? Okay. We may accidentally gain a bit more territory from some other neighbouring continents. Please forgive us.
We are EMEA. We can take a bit of Africa.
Yep.
A bit of Russia.
Yep. Okay, right. So what Rachel is now going to do is Rachel is now trying to stretch that as good as possible to make sure that that will fit on a completely flat piece of paper. This is the projection system. A projection system is how you take that spherical object, you've got to try a bit harder, okay, and you make it fit a completely flat surface. That is the projection system. But we need to make this a bit more complicated.
Yeah, so we need a way to reference where any place on this map where that relates in the real world on the actual Earth. And for that, we need a reference system. So, Andy, do you want to hold this?
Yep.
So, Andy, and then can you also hold this side?
We'll hold it up high so everyone can see.
And do you want to name a place in Europe for me, Andy?
Well, I was going to go with La Scala, which is where I'm going on holiday, and make that the most important. But since Rachel doesn't know her geography and has cut Spain out of Europe, sorry, Spain.
It's very difficult on the large ball.
Europe has suddenly grown a lot smaller today. I'm going to go for the Alps, this big bit of white space. So the Alps, that is the most important place in Europe for me right now.
So we're going to draw an axis there. I just decided to draw where I want, to be honest. But now we have an axis on here. So this is our 0, 0 line, our 0, 0 mark. So I want to measure in meters everywhere from this given start point. I can now measure in meters on the map, and that is a reference point on the Earth. So this is our coordinate reference system. So I've put Andy's coordinate reference system on top of my projection.
Yeah, I think we're good. Thank you, Harry.
Thank you.
So, projection systems. I got a projection system by asking Rachel to stretch out the map. And then Rachel added a coordinate reference system based on the Alps and somewhere that she decided to draw a line. And that is where everything is now referenced, because that was the most important place on the map to Rachel at the time she had that pen. So they are the two things that we need. So if we have a projection and a coordinate reference system, and if you have lots of money and it's really done well with a lot of mathematical checking in the background, you will be given by an agency something called an Epsg code. An Epsg code helps a computer and helps other people understand what projection that data is in and what CRS is being used. Now, if you go away and you download data from PDOK in the Netherlands or the UK, when you go to Census Bureau, you go to Google, you get all of these different pieces of spatial data and you download it in the file and you go, yay, I've got my spatial data. It could be in hundreds of different Epsg codes. So if we look at just Nevada, for instance, Nevada has, well, actually, this is not all of them. This is the list of possible ways that you could get that data when you download it, just for Nevada. Is anybody here from the Netherlands or the UK? Yes, we are small countries and we did it properly. We have one system. Okay, so you download your data, you're going to get it in one. Anybody here from France or Germany or a big country? Okay, you've made things way more complicated. Because you're bigger, in fairness, so you have to. So you could be getting data in lots and lots of different ones of these. Okay, and the bigger you are and the kind of scale of mapping you want to use, you will have lots and lots of different Epsg codes. So especially if you're not from the UK or the Netherlands, you could be feeling a bit like this. Okay, this is me in March when my kids are still watching this DVD every single day in the morning. But at least to start with, Tableau comes to the rescue for you.
Yep, so as promised, we're going to start our journey today in Tableau and look at how we handle this currently.
We are going to make sure that you're able to see this as well, not just us. We would like to share this with you. There we go.
As if by magic. So what we're looking at here is property data for London. And I can aggregate that in multiple different ways. So at the minute I'm aggregating by government district. I can aggregate it by census area, or I can aggregate by NHS boundaries. Now, either way I look at this, I'm not going to be buying a house in London anytime soon, but that's kind of beside the point of the demo. What I want to show you is how we've achieved this. So you can see here that we have my property data came from a CSV, and then I have the 3 separate spatial files that I've joined in. Now we have GeoJSON, .tab, and shapefiles. Now you can't see that here in Tableau, but these are all in different projection systems. Some of these you're able to open in Notepad. So I can see here, we're looking at the census boundary, and this is projected in something called EDM UTM zone 30N. Rolls right off the tongue. And then we have our other one, our GeoJSON file, and we can see here that that's projected in EPSG 4326. So although these are in different EPSG codes, Tableau just handles this for you on the fly. We don't care where your data comes from or what projection it's in. We just deal with that for you. We reproject it to a global projection system, which is the same as the one that Google uses. So what are our key takeaways from projections? So we have these different stretches and these different measurements and ways we can measure the Earth. So it's really important to look out for those EPSG codes to know which one your data is in, especially all across Europe. There can be multiple different ones. But the key thing is Tableau makes this stuff work for us, so you don't need to worry about that. So if that's the case, why have myself and Andy spent the last 10 minutes telling you about projections and coordinate reference systems if it doesn't matter? Well, because when you go outside of Tableau, which is what we're going to do for the rest of the presentation, these things really do matter.
Thank you. Right, so life inside your database is a little bit more harsh. Okay, we are not in Kansas anymore, that magical fairy land where everything's all happy and shiny and it all just magically works for you is long gone. You're in a world of things silently failing when you have the wrong projection, or you're just getting results and they just don't make any sense. And the root of this is just the fact that you've got this little number not matching, or your data, you told your database was in one projection, is not in the correct projection. So this is why we gave you that background to projections, because outside of Tableau you have to know what projections you're using in order to make sure your results will make sense. So why, given the fact that it can be quite tricky, are we actually bothering with spatial databases? Mainly because they can do this. Rather than a standard join, which is what Tableau does today, okay, so Kent showed you what it will do tomorrow, but what it does today is it takes column A, where does it match column B, and then like on customer name or something like that, and join fields together. It can perform a spatial join. A spatial join takes any items in table A and joins that with any items in table B where they have a relationship in 3-dimensional space. So don't just think, so Kent's was a really good example. He was talking about the birds flying over a zone. Are they in that zone? No, they're flying over it. That's 3-dimensional space. So think about it. It's actually 3D when you're doing that join. So because there's lots of different types of relationships, we're going to give you a little bit of relationship counseling now. Okay, so if we move on, this is not a relationship I would like to have. The relationship between this property and the flood zone, we say, is an intersection. This property is well inside that flood zone. That is an intersect relationship, and that covers probably 60% of what our clients would want to do. This is the one that Kent showed. Okay, I want to find out where the properties are inside a boundary in London in order to be able to identify them. But there are many other types of join. I'm going to cover a couple of the key ones now. So the relationship of the boundary of Italy to this road. If I'm driving down this road, the magical boundary of Italy crosses this road. It's a crosses relationship. Okay, so if I was looking for all routes, our delivery routes, and I want to find all routes that cross an international boundary because I want to make sure that our drivers have permits or those kind of things, I'm looking for a crosses relationship. An example here for anybody who came by sea to the UK from Europe. I doubt there's any. Did anybody come by boat? I bet there's no hands. Yeah, nobody does that these days. Okay, so White Cliffs of Dover, the relationship between these cliffs and the sea. They have a very mutually exclusive relationship. They do not get involved in each other's personal space at any point. The sea doesn't go over the cliff doesn't go over the sea. They have a strict touching-only relationship. So it's a touches relationship. They share a common boundary. They never go into each other's space. So unlike big conference centres in the Netherlands or in Germany, if you arrived here today and you were using public transport, you got off outside of the Excel and then you walked in. There are no stations inside the Excel Centre. All of the stations and public transport points are disjoint from the Excel Centre. There's no touching at all. They're not intersecting, they're not touching in any way, the exact opposite of intersect. But more commonly, and the thing that most people want to do is say, are they within distance? Are they within 500 meters? Are they within a kilometer? That can be another type of joining relationship. So given these many types of relationships, Rachel's going to walk you through some uses.
Yep, so now we've had our theory, we've had our relationship counselling. We're going to look at an example of how that might work. So this here is a picture of a very stormy Las Vegas strip. And as I mentioned at the beginning, some of these examples today come from customer use cases. And one that I was helping with last year was before Hurricane Irma hit Florida. I was speaking to a customer who needed to know how many people were in each evacuation zone and the different assets too. So one, how can they get that out and get people out safely? And if they don't manage to do that, what's the contingency plan? So being able to utilize all the tools at your disposal in a situation like this is really important. And we're going to be looking at where is safe in a storm. So the first example here, we did our conference in Las Vegas last November, and I was looking at where to stay after the conference. So I pulled up some Airbnb locations. So these are Airbnb houses or apartments across Vegas. And I want to know which of these are going to intersect a flood zone. I'm not sure how often Vegas actually does flood, considering it's a desert, but I thought it would be a fun example anyway. So what we're going to do now is we're going to utilize some custom SQL to do that intersect relationship, to see where our points intersect with the boundaries, but we're going to have that process done at the database level. So if we go to the underlying data here, so it can be a bit intimidating if you don't know how to write SQL. This example might be a bit intimidating, but Tableau can help you here too. So if we go up here into the data pane, there's an option that says convert to custom SQL. So when I've drag and dropped that table into the view, if I click convert to custom SQL, Tableau is going to give me what the SQL code would be to do that. So you can see here that we're just selecting from my properties table in my SQL database. I have a table called properties, and then I'm pulling in all the different fields that we have. So it's a nice little handy, helpful way to get your code going. Now the next step is we need to pull in our Polygon data set to be able to do that intersect. We want to know which points are in which polygons. So if I swap data sources, you can see the custom SQL is already there. And you can see it's similar to what we just saw. So we've still got that first bit at the top. We're selecting our points. But then you can see at the bottom here, we're selecting a polygon, so our flood zone. So now we have all the ingredients together that we need to bake our cake. And to bake our cake, what we're going to do is we're going to do that join relationship. So we're doing a left join where our properties intersect with the flood zones. And you can see there from Andy's relationship counseling, we're doing the intersects relationship. But this would work the same way if you're using any of the others. Disjoint, touches, any spatial relationship. You would be able to call it here within the SQL code, and that code is evaluated in the database, and the results are sent through. Just to let you know as well, after this session, all these examples will be available for you, so there's lots of picture taking. I don't want to slow down too much, but you'll have access to this afterwards. So we go back to our data set now. You can see that when we did that query, we pull back a field called flood zone. Now you can utilize this like any other field within your data source, and I can drop that on to color. So we can see 5 are the high-risk flood zones and 2 are the lower-risk flood zones. Now the benefit of doing this in Tableau as opposed to a GIS or a spatial analytics tool is that we can see this alongside our other data. So I can come in here and I can say, okay, if I'm going to stay in a flood zone with a risk of 5, how much am I going to pay? How many guests stay there on average, and what's the price? Similar, I can come and swap and see that if I stay in an area with a risk of 2, it's going to be a little bit more pricier, but more people seem to stay there. So it's a nice benefit to be able to have this spatial interaction alongside your other data as well. So what are our takeaways from writing custom SQL? So we can do joins based on spatial relationships, not just our traditional ones between common fields, but we can have joins on how items share 3D space. And it's really easy to integrate in Tableau. We just go in that connection window, and you just have to know a little bit on how to write SQL. But this is an advanced session, so I've got a question for you guys. What is one drawback of using custom SQL? Mumbles, mumbles, mumbles. I'll just tell you. Performance, yes.
Bingo.
Bingo. 10 points at the back. So your custom SQL gets executed on every viz every time. If you're connected live to your data source, every time I drag and drop in a pill, it evaluates that custom SQL before sending the query to your database and getting a response. So if that's quite a complex bit of code, it can take a while to render and affect performance. So what we recommend there, if you're using custom SQL and if your data doesn't change too regularly, is just create an extract of that. So the custom SQL gets run when you create your extract, and then from then on, the queries are evaluated against your extract. So you don't have that extra overhead that comes from using custom SQL.
So that's a great bit of advice from Rachel if your stuff doesn't move. But what if it does move? What if your assets move? And by move, I mean a lot. I mean like this kind of thing. Okay, if I've got a fuel truck that's delivering from refinery A and it's going across boundaries or neighborhoods that you know are known bad, and it suddenly stops and fuel gets siphoned off, I don't want to know about this on my dashboard tomorrow. I want to know right now. Or if we're taking, so former use cases that I've used this kind of thing before, where I have a football stadium, real life use case, they have to have a minimum number of police officers inside the stadium at any time. If any of them walk out for any reason to deal with something else, they need to know right now that they do not have the right number of assets inside this zone. They cannot afford for that to be done, half an hour later when that extract gets refreshed or tomorrow morning. They need to know right now. In the industry that I'm no longer a part of because I'm with Tableau, in my former life, that was known as Geo Fencing, which is just a fancy word for I need to know where my stuff is right now all the time. So it's called Geo Fencing. So how can we get around that? And what did I have to do for my clients? So if we have a look at one of my client scenarios, has anybody seen this film?
Yeah.
Okay. So Tom Hanks was the captain of a large container ship, and they took the crew and the cargo hostage for millions and millions of dollars. Now, you may think that this is an unlikely scenario, but with only a teeny tiny amount of the world's goods being flown around, and people somehow magically think that everything they consume is flown in from all these places around the world. It's not. It's on ships like this. This is a screenshot from marinetraffic.com. The vast majority of our goods and services come by boat. And there are a lot of pirates out there trying to make their living by storming these boats. So the question I had from an insurance company was, am I at risk from pirates? And they needed to know straight away. So let me show you how I help them. So let me have a quick look in my workbook. So if I show you this data source that I have here, let me just go onto the data source pane just so I can show you. This is a direct connection. This is to SQL Server. I have not used any custom SQL. This is a direct connection, exactly as you would make if you just connect up to the table inside of Tableau. So I'm not using any custom SQL because I can't afford that performance overhead for my dashboard, yet I need to know all the time live where my stuff is right now. So what are we going to do? Well, I have created a little bit of custom SQL, but it's called raw SQL. So a lot of people don't use this functionality, but it's extremely powerful. So I've created just one new field. If I just zoom in so that you guys can see that, it's saying here, I would like to select from another table called Marine Piracy Areas. From that table, I would like you to tell me which zone I'm in, which piracy zone I'm in. Now, I could have used just the ST intersect and made this really short. This example I could have made really simple with just a short equation, or short formula, sorry. But what I wanted to show you was, in the real world, you're unlikely at the moment to have all of your customer table, your millions of customers, in a spatial table. Most people don't have that. If they're lucky, they do get a latitude and a longitude, and then they may have the spatial file of where all the piracy zones. That is spatial. So what can we do? So here, I'm actually using Tableau to create a point. So I'm asking it to create some geography in the projection 4326, which is the one that you need, and Tableau is going to parse it, the latitude and longitude, and put it in here. Okay, so we're taking a table that isn't spatial, we're doing a spatial join to a table that containing all of my piracy areas. Okay, so it's a lot lighter weight. And the beauty of this is it only gets run when I need it. So what does this give us? So it means that I can make a map using my latitude and longitude. I told you it wasn't a spatial table, but I do have latitude and longitude. I can break it down by all of the ship's IDs. And now I have this piracy risk field. And if I just drop that onto color, when my database goes through, you can now see that I have areas of high risk, medium risk, and low risk. As you can see, there are a lot of pirates off the coast of Somalia. Don't go there if you've got lots of cargo on board. Okay, so what can I actually do with this? How were they using this internally to find out when their ships were going into the waters that they weren't insured for? Well, they used Tableau server. So if I go to my dashboard, and if I click on something, I'm guessing it would have timed out. Oh no, it hasn't, it's still live. We're okay. So this is my dashboard. You can see that I have a lot of ships in areas of high piracy, I have ships in areas of medium piracy, and all of the other vessels that I'm tracking, and that's fine. But I know that if I click on, say, Rachel, for instance, and have a look at Rachel's shipping portfolio, Rachel's got a lot of ships that are outside of the area, and she's got one in a piracy zone. Her ship is called the Hermes. It's currently in a high-risk piracy area. That's all right. Rachel is insured to have one ship in a high-risk piracy area. If we go and have a look at myself, so Mediterranean tankers for Andy. Okay, I'm also insured for one, but I can see that I've got 3 other ships that are outside. They're very close to this area, and I've got a feeling that they may just try and sneak in at the same time to cut through the Suez Canal. Okay, I need to keep an eye on what's going on. So what I'm going to do is I'm going to say, right, I want to keep an eye on the high-risk ships. I want to keep only, which one is this? This is the Okinawa, big container ship. And I'm going to say, this is Andy's alert view. You can tell I'm not a developer because I can't type quickly. So I'm going to save that. So that is my alert view, and now I'm going to just set an alert on it. I'm going to say, click on the right axis here, go away, alert. Oh, let's go to one that I made earlier. It's always good to have a backup. Okay, I'm going to create an alert, and I'm going to say I am allowed to have 3 ships in there, so as soon as I get to 3, send me an alert immediately. So the second that ship now tracks accidentally into a high-risk piracy area, Tableau server is going to send me an alert. And it's only using custom SQL. So we're using, it's only using raw SQL, yeah, thank you. So we're using raw SQL in this example because raw SQL only gets executed on the individual vises that it's required for. So your business could have 20 other things on your dashboards. That's not best practice, by the way, but we're not talking about that now. You could have lots and lots of other sheets on your dashboard that do not require custom SQL. They do not require a spatial relationship. However, this one little really important viz, that does require it. Okay, for that one, it will execute the expensive SQL in the background, but for all the others, it doesn't. It places a lot less load on your server. If I show you an example of how I've combined both of those together, very, very recently actually for a client. So if I have a look at HS2, so HS2 is a controversial railway that is maybe going to be built across the UK. So people wanted to know how many properties have been sold within a distance of the proposed route, because they want to then try and offer all the people who live close to the route, get them to do a class action for compensation. People near the station, they want to buy their houses, you know how it goes. So what they're doing here is I'm saying, okay, I would like to have a look and visualize what the boundary is like. In this particular viz over here, I'm using custom SQL, as Rachel showed, in order to be able to find all the properties that are within 500 meters, and this is the value of those properties. This is what all of the properties in that particular zone look like. And this is not actually focused on any area. It's just giving me an idea of what that zone looks like. So I could change it. I could say, okay, let's have a look at all the Birmingham postcodes. And I could say I would like to instead look at 500 meters instead of 800 meters. It's now showing me what it would look like. One of the examples on the left using raw SQL. The one in the middle, no SQL at all, or no custom SQL, so it's direct connection. And the one on the right is using custom SQL. So not all of the vises are using the same techniques. You can mix and match the things that Rachel and I have shown you to get the most performant experience for your end users and to answer the questions you need. So if we switch back, that is not Thunder. What are the key takeaways from that? We used the same spatial join as before. The examples that I used were intersects. The last example was an intersect, and it was a within distance query. It's very, very efficient using raw SQL on subsets of your data. It means that you can have things updated much, much more frequently, so they're much more appropriate for alerting. And don't be afraid to use raw and custom together. Have multiple datasets. Have datasets operating in different ways to answer the questions that you need. And with that...
Yep, so the next tool to add to our tool belt is external services. And today I'm going to be talking about Python. But in particular, why is using Python and external services a good match to do with Tableau? Well, on the one hand, in Tableau, we have native connectors to lots of different databases. And by that, we mean we've worked with that end vendor to optimize queries that we're passing to and forth. So typically, if you were to just use Python, you're using the equivalent of like an ODBC connector. So utilizing it in Tableau, you get the advantage of all the hard work that we're doing on the connectivity end. You also are able to analyze your data at the speed of thought. So by dragging and dropping pills into a view, is a nice way to understand what's happening in your data, and the analysis that you find from that is a great way to share across the business in a nice storytelling manner. But on the external services side, what we've got there is we can utilize lots of different statistical, machine learning libraries, and most importantly for this session, spatial libraries. And there are hundreds and hundreds of these available on the web for free, often put up by big companies. Facebook, Google will put up their own algorithms that they've created, and we can all use them for free. It allows us to productionalize those, so you can have one person within the organization who knows how to write this code can write it, and then everyone else can benefit from that. You'll see it in a short while how that would work. And you get more expressive power. It's a coding language, right? So as long as you can code it, you can do it in Tableau. So it's very, very powerful. So as I said at the beginning, I'm going to be talking about TabPy. But what is that? Does anyone currently use TabPy within the analysis? One guy at the back. Okay, so this is going to be an interesting session. So TabPy is a project. It's available upon GitHub. So that's the logo for GitHub. And it's an open source project that essentially installs a Python installation on top of Anaconda. And it has lots of built-in libraries that we can utilize. And it works. It's open source, just like Python, but it's owned by Tableau, so it means we can push updates to it and things like that much more easily. But it essentially allows us to execute code within a Tableau viz. So how does this work? So the first thing you're going to see me do today is we're going to create a script. So within a calculated field in Tableau, we create our script. Then what we do is we throw that over the fence to an external service, my TabPy environment, my Python environment, and it's actually Python or R or MATLAB or whichever you like to connect to that evaluates that code. And then what we do, we get a response back into Tableau. So the evaluation isn't happening in Tableau itself, but we're connecting to the external service. Now, we've had a couple of serious examples. We've had pirates, we've had flooding. I thought it would be time to lighten the mood a little bit. And we're going to talk about tonight's after party. So everyone excited for the day tonight out? Yeah? So, come on, you can do better. Who's excited for the day tonight out? Woo! Yes. So that's here at the Excel, but where could we go after that? So what I'm going to do now is I'm going to call out to Google's API and calculate on a network the walking distance from this venue to some surrounding venue. So not only do you get to know about coding and using Python, but you get some top tips on the local nightlife. So we can see here, so this is the Excel in the middle, and I have some different venues around the side. I believe there's an official after party at the Fox at Excel, and there may be football. This is this one here, which is 11 minutes walk away. But more importantly, how have I created this? So as I mentioned before, I created a calculated field. What we're actually doing here is we need to identify what response we're expecting from Python. So we can see here that we're expecting a script, an integer. So we're writing a script, but we're expecting an integer response. So it could be Boolean, string, real, or integer. Now the next thing I'm going to do is I'm calling out to Google's API. It's called the Distance Matrix API. And what that allows you to do is calculate using a network. So not just physical distance, what you can already do in Tableau, but distance on a network, how far things are from one another. then we're going to pass in an origin and a destination. So similar to the example that Andy showed with the raw SQL, we have special reserved characters when we're talking about external services, and they are underscore argument and then the number, however many you have, starting from 1. I have a couple of print statements, so I can show you some cool things that are happening and how the code is evaluated. But essentially what we want to do is get the results from this. So by calling out to this API, we get a JavaScript response, and I'm going to print that result and also return that result into Tableau. Now the last little bit that you didn't see when I was zoomed in is what refers to these arguments. So origin argument 1 here is actually a parameter in my data set. So I'm typing in a free text parameter of any destination I like, and Google's going to geocode that on the fly for me. And then the second one, our destination, is some preset addresses that I have in my data set. So we have a free text parameter that gets geocoded, and then some addresses that I just have in my list. What I'm going to do now is I'm going to change my location. So as you can see, there's a few venues around the Excel, but living in London myself, I can't say that it's on most people's top list when they visit London. The Excel, unless you're just coming from the airport, people seem to come straight through. So I thought I'd be a bit helpful today and show you, if you just get the DLR to Bank Station, you're in the city, it's 1 train away, and there's much more choice. And I can show you that now. So I've typed in my free text parameter there. That's going to go away and evaluate my code. And while that's running, you can see here, this is the code, the response. So it's running in a command line utility. And you notice I had some print statements. So I printed lots of stars. And then I printed what is the actual JavaScript string that we're getting back. And you can see here where the origin is actually geocoded for me. And then we also printed our response as well. So these are the time in seconds from my given parameterized input to the location of the addresses. And if I spell correctly and don't put a capital T in station, you'll notice from the title as well that Andy is offering to buy the first round for anyone who wishes to come with us.
This is purely for comedic effect and does not in any way help you fund your drinking habits.
So you can see now that the map's changed. We have our destination has changed, our origin rather, is now we're coming from Bank Station, and it's calculating in minutes the walking time from Bank to these venues. So my top tip would be Madison's is really nice. It's a rooftop bar, the one from the slide we just saw, and it has great views over St. Paul's.
However, Harry's does really good cocktails. So sit in the sunshine or have a cocktail.
The sequence. So if I go
Should we take these questions at the end?
Yeah, we can go back at the end, but just I'll show you quickly. So we create the calculation, it's then passed to Python, and it comes back as a table calc in Tableau. But like I said, we can have some deeper questions at the end. So now you know you have some options for the after party. But the main key takeaways from this is that it really does open up a world of opportunities. I just showed one example here, but there's so many libraries out there that you can utilize and start playing around with. Now, the caveat is you do have to have a bit of programming knowledge or know how to code, or at least like most people like me know how to copy and paste from the internet and change it to fit your data. But I touched on this at the beginning as well, but I think it's a really great way to democratize data science. So I've created that code in a calculation, but I can publish that data source up to Tableau server. And then hundreds of people across the organization can utilize that in their analysis. If they're in WebEdit or even connecting to that data source in desktop, they can drag and drop that pill in. They don't need to know how to code in Python, but they get the benefits of doing so. So other examples I've seen customers use is looking at sentiment analysis or analyzing marketing budget, things like that. So typically, they don't need to know how to create the code, but rather they just need to know how to utilize that across the organization.
So last topic for today, we're going to be looking at how you can go about using your GIS. So a GIS is a geographical information system, for those who haven't used them before. They are designed to do one job only, and they do it amazingly well. That is, they perform spatial analysis on your data. However, inside your organization, you'll likely have hundreds or thousands of other data sets that are not spatial data sets. So you want to be able to look at things like customer churn, customer profitability. You want to have a look at sales and profit, all those kind of things. GIS is hideous at trying to do that, but that's okay because you're at a Tableau conference. That means you have the best tool to do that, which is Tableau. So what I'm going to show you today is how you go about taking the best of both worlds. You take what a GIS was designed to do, the spatial analysis. You perform some spatial analysis inside your GIS and bring the results into Tableau so that you can further enhance it with things that you cannot do alone inside a GIS. So everything we're talking about today is based on customer examples. So I'm going to be having a look at this particular example of where's hot in London. So I had a client who wanted to do property analysis. And if we look at our regular mapping options that we have available to us, we've got dots on maps that you can color and sort to try and make an informed decision. Or you can start coloring polygons based on the number of crimes that were there or those kind of things. But I mean, that makes sense if you're talking about census data. When a census collector goes out, they go to house number 1. How many children do you have? House number 2. How many children do you have? And when they get to number 7, they go home. Even though there are lots more houses, they go home because they were told that an invisible boundary on the earth actually exists there. So they just go home. So when you're coloring the polygons based on the number of children in a specific area for census, that makes sense. However, when you want to do this for crimes, if I left my front door open and I had a nice shiny delivery from Amazon with a great big TV sitting in the hallway and I just nipped out to go and see a neighbour, that thief isn't going to go to number 7 and go, I wish there wasn't a census boundary here. I'd love to nick that TV. They're going to just take it. Okay? You need to be able to have something that is not discrete. You want something that's continuous, that continually shows trends across an entire area. And the way we want to do that is with heat maps. Who loved what Kent showed earlier? What I'm about to show you is how you can do that using your GIS and get that into any version of Tableau. And it will enable you to do things that I don't know if Kent showed that. Some things that Kent didn't show that will be coming later, and some things that Kent definitely didn't show because I'm trying to persuade him to make that in Tableau even later after that. So let's have a look at how we go about using a GIS today as a data prep to get that analysis into Tableau. So I'm going to be using, for this example, QGIS. QGIS is an open source GIS package. It's free. You can go and download it. It's the world's most popular open source GIS. And so I've just put a background in so you can see that this is London. Now, I'm not going to cover all of the steps that are needed. For that, you're going to need to download the workbooks and the Word document that will show you all of the things that I'm not telling you today. Okay? But it doesn't take too long. So what I'm going to do is I'm going to start by adding data into my GIS. So I'm going to add data. It could be from a database, but I'm going to add it from a text file. Everybody loves a text file. So I'm going to get a CSV file. And this CSV file contains UK land registry data. So as I said, I'm looking at properties. And it has found a field called X and Y, which contain my latitude and longitude. And I have done this before in a rerun. So it has remembered that this data set is in Epsg. So you have to get the right Epsg code for your data. Other coordinate systems are available. Okay, so when I do that, as I said, this is a GIS and it was designed to do things with spatial analysis really quickly. 4, 5, 6, 7. Okay, so it took about 7 seconds to get 2.5 million rows out of a CSV and put that on a map for you. And I can zoom in and out extremely quickly. Told you it does this thing really well. So what I want to do is I want to turn that into a heat map. Now, if I come over to a processing toolbox, there are lots of things that a GIS can do. We're going to only focus on one of them today. I want to create a heat map. So if I double-click on heat map, I'm going to use my data. And I now have to specify some options. So when Kent just dragged and dropped, everything was amazing. You didn't have to do any of this. That is why it will be so good not to have to do this. But what you have to do is, let me show you how a heat map works, actually. So if I just zoom in and I turn the background mapping off just for a second, what does a heat map actually do? Let's just take these 3 points. A heat map is going to take a buffer of around this property. This is not a perfect circle, but it's going to take a buffer of a distance that I specify. I'm going to say 1,000 meters. It's going to buffer the next one by 1,000 meters. It's going to buffer this one by, okay, I didn't get a perfect Venn diagram there, by 1,000 meters. But in the middle here, where all three overlap, I would have a number of 3. Here I would have 2. Here I would have 2. Here I've got 1, 1, 1. Classic Venn diagram. And it's going to do that for all 2.5 million points that I've got on the map, and it's going to create an output to show where I've got the most overlaps. That is the density. That is what heat map is doing. And in Tableau, to change that density, all you're going to do is, oh, Ken didn't show that, all you do is just drag the size slider. Yay, it's simple. Okay, but you can't do that in a GIS, so you have to specify some options. Those options are, I want to use my data layer. I'm going to specify a radius, I'll zoom in on this in a second, of 1,000 meters. That's how far away the sale of one property could affect other properties. That's the buffer I just drew. I'm going to say I want an image output that's of a certain size, lots of different types of options that you have available, and I just hit go. And now it's going away and it is building a heat map for me. So it only takes a few seconds to create a heat map. This heat map is going to be not as refined as an image that you would take on your iPhone, which is like 12 megapixels. This is going to make a 1 megapixel image for you. As I said, it's doing a lot of work in the background. If I zoom out so you can actually see this, whoa, not out to the entire world. Okay, there we go. And I look in London. Let me apply some color for you, just so we can see a little bit better what that looks like. So I'm going to have pseudo color. There we go. You can now see I'm spotting a trend. This is the initial heat map. Now what Kent didn't show you and will be available at some point in Tableau, maybe release, I'm not quite sure, you can have different options that are extremely powerful. Why are they so powerful? Let me show you. So I'm going to put in the radius. So we're still doing the circles, but instead of giving every house a value of 1 on those circles, which shows you density, it just shows you where lots of those points were, shows you where there were lots of transactions. I'm actually interested in how hot was the property market. I need to know how much those properties were worth. So if I can replace the number 1 in all of those circles with how much that property was actually sold for, I get a very different map. So I'm going to say I would like to weight from a field. If I zoom in so you can see it, I'm now able to weight every one of those circles by a price. I've created a script that does this for you, so you can double click, point it to a layer, it will run through and make the output. So I'm going to now say I would like to weight it based on the price. I'm going to choose some other options that I'm not talking about right now. And make sure that I do this. It goes through, it makes a brand new heat map. So now this heat map, instead of just showing density, it's showing density and heat. The heat related to how much those properties showed for. And I'll show you the difference ever so quickly as soon as it finishes. There we go. And I'll put the same color on just so that we can compare like for like. We do like a bit of visualization. There we go. And if I turn them on for now quickly, you can see we get quite a different trend emerging, because one is just showing the density of points, the other is showing the heat that is actually there because of the price that that property sold for. And this is what my client was interested in. So how do we go about getting that into Tableau? I don't just want a pretty background image and everyone goes, yeah, you've got heat map. I want this to be useful. I want to do something with it. I want to select properties. I want to use it to do real analysis. So what I do is I pretend that these are mountains. I pretend that those colors are looking at a beautiful mountain range. And what do you normally see on maps of mountain ranges? Contour lines, exactly. So I go away and create contours with another. There we go. Oh, have to give it an input layer, otherwise it won't know what to do. There we go. Run it in background. It's done it. Can anybody see those contour lines in the background? So we're getting close to the thing that you want inside the Tableau. We're a few steps away, but I'm going to now switch to Tableau and show you what we can do with that. So I have now a data set. Let me show you the actual data set so you can see how it's joined. And registry. So I have joined to, come on, okay, don't worry about it. I was going to show you, I've got my properties table and I've got my heat zones, and I've done a join between the two based on the ID of the property and the heat zone that it's sitting inside. And what it means that I can do is I can create a heat map using my polygons. So I now have my polygons on the map. I can break them down by the zone or the heat level. I can say that I would like to get rid of the boundaries. And I can say that I would like to weight that by the amount of heat. And I'm going to say that this is going to be treated as a continuous measure. You can see we're gradually getting there. And I'm going to choose a custom color palette, not one of the ones that Kent supplied. And now we can zoom in and we can see those trends inside of Tableau. Okay, so this is one way that we can get the same pretty output, but what can we actually do with this? What kind of things can we enable you to do inside of Tableau? Well, firstly, we can enable you to use that for selections. Oh, this is taking some time. So this is performing a spatial calculation. I've now got all of the properties in London, and I want to use this heat map as a selector to find properties. So if I now go and say, actually show me all the properties of about this level of heat. Can you see when I just hover over a kind of reddy orange area, can you see it's highlighting them? If I now click on that, it's using it as a selector. So now it's showing across the whole map for properties that are sold with a similar level of heat, irrespective of where they are in London, and a similar level of heat means either there was a high level of transactions or there was a lot of money changing hands in those areas. Show me the properties in those areas. And now the visualizations underneath are showing me, for all the properties in the ones I've got selected, which of those are outliers, which are the ones that were really expensive for that kind of area, and which are the ones were really cheap for that kind of area. So this is what they wanted to do. Now they weren't using land registry data, they had real sale data. So there obviously you can see in my land registry data I've got some very low values. If you ever find a property in central London for £60,000, please let me know. I will be on that straight away. So you have to know your data and know what these things are. These are normally where people have shared apartments or somebody's getting a divorce and they have to take out a mortgage for X amount to give to somebody. It still registers as a transaction. That's why you have these low values. But we're enabling you to actually use the heat map as a selector to find insight in your data. Now, one of the things that I wanted to show you is the way that you can actually control the color palettes in your data. So we'll leave this for now. So when you create custom color palettes, and you remember to put them on the laptop that you're demonstrating from right now this second, you will be able to create color palettes that look slightly different to this. So this is a custom color palette. This is not one that will actually come with Tableau. This is one that I've created. When you download the workbooks, you will find that this custom color palette and others are available. I've created some specifically for the purposes of using on heat mapping. Now, what I normally do is at this point I will show you how you can flip the color chart around. So if I zoom in and I start to draw, or if I just start to draw here actually, you can have at the very top range, in this area at the minute, I know that everything's red. If I asked you in your local city, where's the most crime? In the middle, right? That's where the most incidents are. That's not really of interest to me. I've wasted a lot of my visual bandwidth by all the values that are high just being in the middle. So what you can do is you can extend with a custom color palette the range of values that you can see by actually putting an inverse color palette. So at the moment I have a color palette at the top that goes from blue to red. When I get to that red part, if I spin it around and then start again, so I actually start right over from white going to pink, you will see in the very hot areas, where's the hottest area, are there multiple areas? So it enables you to highlight different things. It will show you in the suburbs on the same visualization without having to change levels, without having to filter things in or out. What are outliers in these regions that I'm unable to see right now just by using different color palettes? So the ability for you to change the color palettes and use different ones, which will be available when you download these workbooks, is a really powerful tool. The standard color palettes, if I just go to a standard one on this visualization, doesn't enable you to see the same kind of insight. So if I just switch to a standard Tableau one, for instance, you don't get the same kind of dynamic visual range out in the suburbs. Okay? So color palette has a really big impact when you're using heat mapping. So if we switch back, key takeaways for heat maps: you can use your GIS as a data prep tool. Okay? Get a GIS and use it what it's designed to do. Heat maps are ideal to show spatial trends, not just density, as was shown by Kent, but also density based on a value. You can use it to be weighted. And don't waste your visual bandwidth. You can use custom color palettes to further enhance the analysis that you're going to do. Don't just stick with the ones that are in the box for Tableau. Go outside. When you have a look at GIS and when you have a look at heat maps, you will see that there are lots of different types of color palettes to help you see things much more easily. So this is the end.
Yeah, you sound surprised, Andy. What did we just learn? So Tableau helps people to understand complex spatial problems as well as all the other business data too. But for each example that we showed today, there was a different challenge and we had a different tool that was best suited for that problem. So it's important to know all the different tools at your disposal and which one fits the situation the best. And also Tableau is just the start. So you can take analysis from all these different areas, put it into Tableau, and we encourage you to do that on your own business data. Hopefully you are slightly inspired, can see how you can utilize this on your own business data, and myself and Andy are available for any questions that you have.
And whilst we're taking questions, we'd love for you to fill out the feedback in the app. So if you go to our session on your app, at the bottom it asks for feedback. If there's anything you think we should do differently, if, like most people, you think that Rachel and I talk too fast, please put that in the feedback and we will try and take it into consideration at some point in the future. If you think we should cover different topics or go into more depth or less depth on certain topics, please let us know.
Yeah, a really important point about this, so there's a star rating at the top, but what we want you to do, there's a short survey link at the bottom, which is a little bit hidden but very important. So if you scroll down to the bottom, click the survey link, and then you'll be able to give us all your lovely feedback.
Thank you.
Yeah. Thank you.